My name is Matt Liebman, and I serve as the Henry A. Wallace Chair for Sustainable Agriculture, and I'm in the Agronomy Department here at ISU. And I'm pleased to welcome you to the 8th Annual John Pesek Colloquium on Sustainable Agriculture. 7 years ago today, we in the United States witnessed acts of extreme violence against several thousand innocent people with the attacks against the Twin Towers in New York City, the downing of United Airlines Flight 93, and a substantial portion of the Pentagon building destroyed. These tragic and horrific acts were our particular experience of violence in an increasingly interconnected world, where isolation from conflicts and tensions in other parts of the world can no longer be assured. For many of us, these acts were a potent reminder that most of the important challenges we face today are global in scale. These same events also provided striking examples of courage, kindness, and compassion, the human qualities that inspire us and give us hope that we can meet the large challenges facing our planet now and in the coming decades. Tonight, on this anniversary of September 11th, 2001, we'll hear a lecture focused on the role of ecological economics in creating a sustainable and desirable future, including sustainable agricultural systems. I'm honored to introduce our speaker, Dr. Robert Costanza, Gund Professor of Ecological Economics and Director of the Gund Institute of Ecological Economics at the University of Vermont. Dr. Costanza's career has been devoted to addressing with hope and with creativity the large challenges facing us at the interface of ecological and economic systems. He was co-founder and president of the International Society of Ecological Economics and a chief editor of that society's journal. Focal areas of his work have been the relationship between energy use and economic activity, management of coastal wetlands and ocean systems, and valuation of ecosystem services. With economist Herman Daly, Dr. Costanza has clarified the difficulty of living in a full world in which resources are increasingly depleted and waste products and pollutants are increasingly abundant. He and Dr. Daly have also stressed the importance of economic development over economic growth per se. In his recent writings and talks, Dr. Costanza asks us to consider what constitutes a high quality of life and what are the appropriate paths at the interface of ecological and economic systems for achieving that quality. After his talk tonight, there'll be time for Dr. Costanza to answer questions. In addition, the slide set that you'll see and a paper version of his presentation are available at the website of the Wallace Chair for Sustainable Agriculture. So if you go to the Iowa State page, navigate to W, look for Wallace Chair, and you'll see on the entrance port there a place to download both the talk and the slide set. Dr. Costanza's presentation is part of a series named for John Pesek, an emeritus professor of agronomy and former dean at Iowa State University. Throughout his long and distinguished career, Dr. Pesek has made important contributions to human well-being through the disciplines of agronomy and soil science. He has also addressed in considerable depth and breadth the challenges and diverse paths to agricultural sustainability. This series honors his lifelong commitments and contributions, and I'd like to acknowledge him here tonight, Dr. Pesek. Dr. Costanza's visit to Iowa State University has been made possible by the hard work and organizational talents of Ms. Marsha Manier. It's also been made possible by generous donations from the Iowa Farm Bureau, Iowa Farmers Union, Practical Farmers of Iowa, Alliant Energy, the Leopold Center for Sustainable Agriculture, ISU's College of Agriculture and Life Sciences, the Department of Agronomy, the Department of Natural Resource Ecology and Management, the Plant Sciences Institute, the College of Engineering, the College of Liberal Arts and Sciences, the Bioethics Program, and the Committee on Lectures. On behalf of the Pesek Colloquium Committee, I express my sincere thanks to all these organizations for their assistance and support. Let us now welcome the 2008 Pesek Colloquium speaker, Dr. Robert Costanza.
Thanks. Thanks very much for that, Matt. How did you ever get all those organizations to agree to, to have me come here? But that was quite a feat. So thanks very much. I want to talk tonight about ecological economics, a bit what that means, and how it can help us to create a more sustainable and desirable future, and tie that in with sustainable agriculture a bit. First, I want to point out something that's really dramatically changed just in the last 100 years. And we've moved from a relatively empty world of humans and their artifacts to a relatively full world. Some in the geology profession are even calling our current era the Anthropocene. So we've moved out of the Holocene era into the Anthropocene because humans are having such a dramatic influence on what's happening on the planet. This is just the nighttime satellite imagery of the Earth, pasted on this rotating globe. So you can see the intensity of human activity around the planet. And this is a relatively recent phenomenon. A lot of our ideas about economics and other things were developed during an empty world era, when there was still a frontier, when we had not begun to have such dramatic influences on the underlying ecological life support system, including the carbon cycle and the nitrogen cycle and the climate, etc. So this has dramatically changed. We're in what some people have called a no analog world as well from a historical perspective. We've never been in this particular situation in terms of climate and other influences. So it's incumbent on us to change, I think, our vision of both what our role is on the planet and our influence on our underlying life support system if we hope to create a sustainable and desirable future. A lot of this has been driven by the exponential increases in the consumption of fossil fuels. This is a plot of oil production, oil and gas liquids, from 1930 up till the present, and projections into the future. Some of you have probably heard the term peak oil, and many geologists, including Colin Campbell, are projecting the peak of oil and gas production right about now, sometime if we haven't already peaked. And that's evident from the history of new discoveries, which lag production or lead production by quite a few years. So we know that discoveries have gone down quite dramatically. And this is actually a rosier picture than reality, because that's plotting gross production. If you look at the net energy, the amount of energy that's left over after we've subtracted off all the energy that it takes to find and drill and explore and produce and deliver that oil, the net energy is going to decrease even more quickly because now we're looking at harder to get resources in the form of tar sands and far offshore resources, etc. And also the geographic distribution of the remaining supplies of oil is quite concentrated in places that are quite difficult. The black circles here are the remaining oil and gas reserves. The red circles are the initial or ultimate oil and gas reserves. So you can see we've used up quite a bit of our initial reserves over here in the U.S., and the remaining reserves are concentrated over here in the Middle East. So we need to break our addiction, I think, to fossil fuel if we hope to create a more sustainable and desirable future. We're also learning quite a bit more about the way this ecological life support system functions, and particularly the climate system. This is a plot of a global circulation model from NCAR, the National Center for Atmospheric Research, which shows in white relative humidity and in orange precipitation. So we're able now, after several decades of very intense work, to synthesize a lot of information in the form of these kinds of models that can, in one place, present a very compelling picture of how the Earth's climate system functions. Pardon? No. So you can see that it picks up most of the major features of the climate system, the intertropical convergence zones and the fronts moving across the northern and the southern hemisphere, and the influence of mountain ranges and and other things. Of course, the purpose of doing these kinds of models is so that we can understand the implications of making changes in the system, like increasing the concentration of CO2 in the atmosphere, changing land use patterns, and other things that we're doing to affect this global system. And we can also look historically at what has happened to the Earth's climate, and using information on ice cores and sediment cores and tree cores, we can reconstruct the climate back quite a distance into the past. This plot goes back 1,000 years and shows that historically the Earth's climate has been relatively stable over that time period. This is the historical record where we've actually measured temperature, and you can see that there's a definite increase over that historical period due to the production through fossil fuel burning of all the CO2 that's gone into the atmosphere. And here's the projections of all the various climate models like the one I was just showing. There's a whole suite of these models and under different assumptions and different scenarios, but they all show an increase in temperature projected over the next 100 years, anywhere from 2 to 5 or 6 degrees centigrade. That may not sound like a lot, but in terms of the impact on that climate system, it's quite significant. This is from the recent Stern review on the economics of climate change, which was done by Nicholas Stern, the former chief economist at the World Bank, working for the British Treasury. And they looked at the economic impacts, both of doing something about climate change. If we were to take the actions necessary to keep temperature increases less than 2 degrees centigrade, below which many of the more severe kinds of problems don't start to occur, they estimated that would cost about 1% of global GDP. But if we don't take those actions, if we allow climate to progress beyond that point, the cost would be on the order of 5 to 20% of global GDP. So the bottom line conclusion here is that we need to take these actions now in order to prevent some of the more extreme damages that might occur farther in the future. Many of these are still uncertain, and it's not clear exactly when those damages might occur, particularly the risk of abrupt and major irreversible changes, extreme weather events, and we're already seeing, I think, some of the implications of that with increasing flooding and storms and hurricanes. Effects on ecosystems and the services that they provide, and water and food. So we're at a very critical period. And I think we also need to look a little further into the past and look back over the entire range of human history to better understand what actually leads to sustainability of societies or the converse. The collapse of historical societies, and most historical societies have collapsed eventually. So what can we learn from that, from that history? How do we learn from it, not to predict the future, but to be able to create a more sustainable and desirable future? If you look over the broad sweep of human history, and I'm sorry you probably can't see the details on this graph, but this is a plot with time going from the bottom up to the top on a log scale. So this is 100,000 years ago, 10,000 years ago, 1,000 years ago, and 101. And this is an attempt to put some of this information together. We need to build a more integrated history of people on Earth in order to create this sustainable future. And what this shows is just some of the technological changes, some of the civilizations that have come about. And this red line is interesting. This is the temperature reconstruction going back 100,000 years ago, showing that biologically modern humans have been around for about 200 or 250,000 years. During that whole period, we were hunters and gatherers, and the climate was rather erratic, going from ice ages to interglacial periods, and it was quite erratic. Right here at the beginning of the Holocene, the climate stabilized quite dramatically, and that allowed sedentary agricultural development. It allowed basically the development of civilization and all of these graphs to take off. You can see here what's labeled the start of the Great Acceleration, that there's a kink in the curve in the post-World War II period where we really started cranking up the use of fossil fuels and all of our indicators of population and GDP, et cetera, really started growing even hyper exponentially. So the real question is, we've operated historically in a very narrow range of climate, although there have been some ups and downs. The Little Ice Age, the Roman climate optimum, and we can better study these periods and try to understand how historical societies have become non-resilient. How have they lost their resilience and allowed collapse, or how have they maintained their resilience and allowed sustainability over that period? But also, what can we say about our ability to survive outside this relatively narrow climate range in which civilization has evolved? You may have seen Jared Diamond's recent book on this topic called Collapse: How Societies Choose to Fail or Survive. Again, making these same points. And he recognized that he had this list of 12 different causes that face past and future societies of potential collapse, ranging from loss of habitat and loss of ecosystem services, overfishing, loss of biodiversity, et cetera, energy, freshwater limits, climate change, population growth, consumption levels, et cetera. I think a key point here, though, is that it's almost never just one of these causes that has led to the collapse of historical societies, but several of them acting together, and particularly when societies have become brittle or have lost their resilience, at which point any one of these causes can push societies over the edge. So how do we better understand those sorts of phenomena? I think this is an active area of research. How do we apply the scientific method and scientific thinking to our integrated history so that we can create this more sustainable and desirable future? We know that these changes are already occurring. We're seeing increasing frequency and intensity of storms. We're seeing increasing numbers of flood events. This is from the Millennium Ecosystem Assessment across all of the major continents. Dramatic increases in numbers of flood events. And we're also beginning to recognize that there are potential tipping elements in this climate system. This is from a recent paper by Tim Lenton and others, identifying some of those potential tipping elements, like the melting of the ice sheets you probably heard about. There's also the potential for major changes in the ENSO, El Nino effect that affects global climate, the potential dieback of the entire Amazon rainforest, which could occur and convert that into savanna, which would have major impacts on the global climate, and several other things. So there are these possibilities for very dramatic changes that are not really well picked up in the climate models that are nonlinear effects that we know, however, may occur. So the question I want to concentrate on tonight is, in this new full world context, in this environment where we are already having major effects on our ecological life support system, what do we mean now by the economy? What is really the economy, and what is it for? And I think the conventional view is that the economy is merely the market economy, all the things that are exchanged in markets. And I think that's far too narrow a view of the economy, that the real economy actually extends out to cover the entire Earth system, because that system provides welfare, provides goods and services that support human well-being. And it also extends to all of our social capital, our social interactions, as I'll get into in a bit. And the purpose of the economy is not merely to produce more goods and services, but it's to create and maintain a high quality of life for everyone on the planet, and to have that be sustainable. So I think there's a different set of goals and a different set of assumptions that go into an empty world versus a full world view of this question. Just a little more detail on this empty world model of the economy. The traditional sort of view is that there's these primary factors of production: land, labor, and capital. But you can see that land is sort of grayed out in this model because it's assumed that there's almost perfect substitutability between these factors, that if we run out of land or natural resources, we simply substitute more manufactured capital or labor. We can keep the economic process humming and growing, and that the entire purpose here, the premise, is that more is always better. The more we consume, the better off we are. The major policy decision is how much do we consume now and how much do we invest in building more capital so that we can consume more in the future. And the idea is that this economy can grow forever. There's nothing in this vision of the economy that in any way constrains its growth into the indefinite future. And that property rights are relatively simple, private versus public, and that private property is usually considered to be the best approach to managing things in this economy. And I would argue that this model still motivates and underlies a lot of the policy that's being made in economies all over the world. It can be carried to extremes. This is an ad that I found in an in-flight magazine from Alabama Power, and their motto is "always on." So you can see what they would like to see from space at night is, the state of Alabama completely lit up. And their question is, why not? Why can't we just continue growing like this indefinitely? Well, the answer is you can't. And the reason is we do live on a materially closed Earth system. The Earth itself is finite. We can't have material economic growth indefinitely on a finite planet. There's also some other problems with the empty world model in this new full world context. There's not unlimited substitutability between these major types of capital. Their substitutability is limited, and we have to consider four major categories of capital, stocks, or assets, including conventional manufactured capital. Human capital, instead of calling it labor, we call it human capital just to emphasize that it's more than just physical labor. It's the information stored in people's brains, all their health, all of the attributes of individual humans that allow them to function. But then there's also social capital, which is all of the interactions, formal and informal connections and networks and institutions between people, without which none of this could happen. The market itself is a form of social capital, as are governments and religions and all kinds of social institutions, universities, and also natural capital, natural ecosystems, and all of the services that they provide, some of which are required for conventional economic production, but some of which are also influence human well-being without ever going through the market system. We have to recognize that this production produces waste as byproducts, which has disamenity effects, and that human well-being is a much more complicated function than simply the more, the better. In fact, we're finding with recent psychological research that it's relative consumption rather than absolute consumption that affects people's sense of well-being. And there's a whole range of non-consumption related factors that influence people's sense of well-being and satisfaction. So going back to what our goals are, what the economy is for, if the economy is to create and maintain human well-being, then we have to better understand what contributes to that well-being and recognize that it's more than simply the production of goods and services. And what contributes to the sustainability of that well-being in terms of all of the different types of capital that we're talking about. One way of summarizing some of those ideas is to think of quality of life as the real goal for our economic systems, and recognizing that it has at least these three major components, that there's the idea of subjective well-being, and there's been a lot of research on this idea through various kinds of surveys. How do people feel about their happiness? If you ask people, how satisfied are you with your life? You'll get answers, and they've done this across many different countries and across different people within countries. And that's an important component of quality of life. Another important component is this idea that there is a cross-cultural set of basic human needs. Going back to Maslow's ideas, but more recently, Manfred Max Neef and several others, Amartya Sen, have also identified this sort of basic set of human needs, one of which, or some of which, have to do with basic subsistence and consumption of goods and services, but many of them are not related necessarily to that consumption. They're more affected by our social and natural capital assets. The weights that people attribute to how well these needs are met in terms of their subjective well-being vary across cultures and across individuals. And what we can do, really, from a policy point of view, is to create the opportunities for people to meet those needs and to feel this level of subjective well-being. So how we arrange our built human, social, and natural capital assets and how we use our time are really our big policy levers. And how we view this entire complex of quality of life and opportunities, I think, needs to be more of the policy agenda in the future rather than simply maximizing production. So ecological economics tries to address this broader image. It's not a broader question. It's not a subset or a subdiscipline of economics. It's not a discipline at all, really. It's more of a transdiscipline that tries to integrate across the natural and the social sciences and the humanities. You probably know that both ecology and economics come from the same Greek root, oikos, which means house. So ecology is literally the study of the house. Economics is the management of the house. We need to do those two functions in a more integrated way. It has three integrated questions or goals. The first being that we need to understand what an ecologically sustainable scale or size or magnitude of this economic subsystem is within that will allow it to be sustainable within the ecological life support system. We need to create and maintain a socially fair distribution of resources, both within the current generation of humans, but also between the current and future generations, and also between humans and other species. And we need to have an economically efficient allocation of resources. But in order to do that, we have to include in the allocation mechanism all of the things that contribute to human well-being. And as I said, many of those things are outside the market. So our market mechanisms currently are not giving us a very efficient allocation. They're certainly not giving us a fair distribution. And it's arguable whether we've already surpassed the ecologically sustainable scale of economic activity. How do we address those questions and reach those goals? Well, we need to transcend the disciplinary boundaries. We can't study and address these questions from within any one academic discipline, obviously. We need to focus more on problems rather than tools. We need to develop a more integrated approach to science that balances synthesis and analysis. We're very good in science at analyzing things, taking them apart into smaller and smaller pieces. And that's one side of the coin. The other side of the coin is how do we put those pieces back together to create a picture of how the whole system functions. And we need to better balance those two sides of the coin. And we need to create more effective and particularly more adaptive institutions, ones that can learn from their behavior. So just another way of presenting this, back to what is the economy and what is it for. If the economy is for creating this sustainable human well-being, then we need to consider the contribution of all of these four major types of capital and develop a better understanding of how these opportunities can create a sustainable future with a high quality of life for everyone. There's just some data to back up some of this. If you plot GDP per capita on this axis versus the life satisfaction as measured by the World Value Survey on this axis, you see that there's sort of a saturation curve here. Beyond a certain point, additional consumption, additional GDP per capita is not really improving people's sense of life satisfaction. There's a region in this curve where certainly we need to increase production and consumption in conventional terms. There's also a region where we probably don't need to increase production and consumption. We could even reduce it and still have as high a quality of life as we have now. How are we measuring our progress these days? Well, GDP, GNP are the primary measures, but these were never designed to be measures of economic welfare. They're really measures of economic income, and they're only the marketed part of that economic income. So you can get some very weird kinds of conclusions if you're trying to maximize GNP, because if there's an oil spill, someone has to go and clean it up. That leads to increased GNP. If there's more air pollution and more health care because of that, that adds to GNP. If there's more storms or wars or pestilence or many of those kinds of negative things, crime, that actually increases GNP. So it's not GNP that we want to increase. GNP is really, as Kenneth Boulding said, is really gross national cost. So we don't want to necessarily to increase all of those costs. We want to separate out the costs from the benefits, and there have been some attempts to do that with alternative measures, including this Index of Sustainable Economic Welfare as one of them. And there have also been some efforts to look more directly at human needs and how well human needs are being met through surveys and other sorts of techniques. So really, when we talk about economic efficiency, we should be talking about how much human needs are we meeting for the least amount of GDP, for the least amount of cost, not equating costs with benefits, particularly in this new full world context. Now, you can argue that when GNP was created, that was the limiting factor. The limiting factor in creating new welfare was producing more goods and services, more built capital infrastructure. And if you look at the comparison between GDP and these alternative measures, you see that they correlate over a historical period, but they've lost that recently. Before I get to that, let me just tell you a little bit more of what goes into this Index of Sustainable Economic Welfare or Genuine Progress Indicator, just as an example. Not the perfect indicator, but at least one that tries to take on board some of these ideas. It starts with personal consumption expenditures, but then it weights those by the distribution of income to recognize that a dollar's worth of income to a rich person doesn't produce as much additional welfare as a dollar's worth of income to a poor person. There is this saturation curve that occurs. It adds on a few things that are left out of GDP that are obviously contributions to well-being, like the value of household labor and the value of volunteer work. And then it subtracts a bunch of things that are really costs and shouldn't be added on, like the cost of crime, the cost of family breakdown, underemployment, the loss of leisure time, the cost of commuting, and a whole range of natural capital factors, the cost of air and water pollution, loss of wetlands, loss of farmland, etc. When you apply this measure, this ISEW versus GDP for a range of countries, you see that there's some interesting kinds of behavior. In some places, it's correlated quite well for a long period of time. In the U.S., from the 50s until about the 70s, there was a very good correlation between increasing GDP and increasing real welfare. But beyond that point, the increasing costs and side effects of this economic growth have begun to balance off the benefits, and we've seen a leveling off and decline of GPI or ISEW relative to GDP. This is the U.S. in a little more detail, starting in the 50s and going up to about 2004. And so you can see that since about 1975, we've more than doubled GDP, but our real genuine progress has really leveled off and declined a bit with some ups and downs. So we're in a period of what Herman Daly has called uneconomic growth, where the economy is growing, but welfare is not improving, so it's not really economic in a real sense. Before that period, from the 50s to about 1975, you can see there was a good correlation. A lot of our economic policies and ideas were formulated back during this relatively emptier world period. This is backed up with surveys of life satisfaction, which also have not increased since the mid-70s in the U.S. and in many other countries. Just to show you that it's not the same everywhere, we did this study in Vermont, for the state of Vermont and for Burlington and for the county that Burlington's in, showing that in that case, even though the U.S. average was leveling off and declining, in Vermont the GPI per capita continued to increase, largely because of better concern over the natural capital and the social capital assets in the state. So what are we talking about in terms of how we need to reconceive the economy and the role of natural and social capital in contributing to human quality of life and well-being? Well, one way of thinking about those assets are that they represent the commons. They represent assets that are gifts that we either inherit or create together, as Peter Barnes has called them in his recent book, Capitalism 3.0. And his idea is that we don't want to throw out capitalism, but we do need an upgrade to the operating system. The operating system is about to crash the larger system. And so we definitely need to do this upgrade. And the major component that's missing from Capitalism 2.0 is how it deals with the commons, how it deals with these assets that are currently open access, like the atmosphere, the oceans, air, water, ecosystems, but also our social commons, languages, money itself. The market itself is a form of social capital that belongs in the commons. The internet is a form of the commons. So how do we deal with those common property assets? And it's been estimated that the value of those common assets for the U.S. economy far exceeds the value of our private assets and state assets taken together, including the natural and the social asset components. So it's not trivial. You can't really call yourself an economist, I think, a real economist, if you're only dealing with a half or less of the real economy. So we need to bring on board this other major sector of the economy and start thinking about the common sector of the economy as well as the private and the public sector of the economy in order to get to version 3.0 of capitalism. So a major component of that, of those common assets, are ecosystem services, as we call them, the benefits that people derive from functioning ecosystems. Here's a list that we put together for a paper back in 1997 that looked at the whole range of services that provided by natural ecosystems, ranging from very global level things like climate regulation, water supply, water regulation, controlling erosion and sediment retention, forming soils, cycling nutrients, pollination, food and raw material production, recreation, cultural amenities. So a list of 17 different services that natural ecosystems and agroecosystems also provide. The recent Millennium Ecosystem Assessment, which some of you may have seen, repackaged these services into these four major categories of provisioning, regulating, cultural, and supporting services, and identified their relationships, their complex relationships to the various constituents of human well-being. So I think this is a major reframing of the whole environmental issue, that we're not talking about the environment merely as a pretty picture, but recognizing that the environment is absolutely essential to maintaining human well-being in various components. And we need to recognize that and value that appropriately. As far as agroecosystems are concerned, you can think of the variation between the production of these various services from a natural ecosystem, and you can see that wild foods and crops are a minor component, whereas these other services are major components, compared to intensive cropland, where the crop production becomes the major element at the expense of many of these other ecosystem services. But one could think of a more integrated kind of cropland system with many of these ecosystem services restored while maintaining a high level of crop production, but also adding in this whole range of other ecosystem services. So in terms of creating a more sustainable kind of agriculture, I think we can think about how do we begin to reintroduce many of the ecosystem services that we've been ignoring in our conventional kinds of agricultural production. It's important to know the relative contribution of these different services to human well-being, and there are several ways to value these services. And this is just a list of some of the techniques that are out there. Not an exhaustive list, and certainly there's, I think, a lot of room for research and improvement on many of these. And I'll just mention a couple of them. I'll give an example of how to use this idea of avoided costs to value the flood control services of coastal wetlands. We can look at how much we would have to pay to replace some of these services. We can look at how much people would be willing to pay if they were asked in surveys to pay for the services. And a couple of newer ones which have to do with if we recognize that these ecosystem services are actually community or public goods and not private goods, then we shouldn't necessarily be asking people as individuals to value them, but we should be asking the whole community as a group to value them. And we may need to, for many of the services that don't intersect well with people's perception, we may need to do a significant amount of modeling behind that in order to understand the production functions of the services and how they connect to human well-being. We also need to recognize that when we value something, we're really talking about the contribution of that thing to meeting a particular goal. And there are multiple goals that we're pursuing. The conventional goal of economic efficiency is only one of those goals, and we have the conventional kinds of techniques to approach to estimate that. But we also have the goal of, as I mentioned, of social fairness and ecological sustainability. We're going to need a whole different set of methods to address and analyze and understand the contribution of things to, for example, the goal of fairness or sustainability. We also need to understand the way that these services vary in space. There's a whole, this is just one way of reclassifying them according to their spatial characteristics. There's some like carbon sequestration and climate control that don't depend on proximity to human settlements. It doesn't matter where on the surface of the Earth you extract the carbon from the atmosphere. The atmosphere is fairly well mixed. Other services depend very heavily on the proximity of the ecosystem to the infrastructure or the human settlements that are being protected, like storm protection services. There's some that are related to the flow of water across the landscape, water supply, sediments, nutrients. So in those cases, we need to understand the horizontal flow of water across the landscape. There are some that are related to the movement of people from where they are to where the ecosystem is for recreation, for example. And there's also, you also need to recognize that many of these services are public goods. They're not rival, they're not excludable. Rival meaning that if one person consumes a resource, a good or service, that someone else can't also benefit. Many of the services are non-rival, that if I benefit from a good climate, that doesn't prevent you or anyone else from also benefiting from the same climate. And they're also non-excludable. It's very difficult to prevent people from benefiting from a good climate unless they pay you, like it is with private goods. So the market and market mechanisms are really good at dealing with rival excludable goods, market goods and services. They're not very good at all at dealing with non-rival, non-excludable public goods and services. So I think we need to just recognize those distinctions and use the market where it works well and use other institutions where the market doesn't work well. I'll run through a quick example of how to value ecosystem services. In this case, the value of coastal wetlands for storm protection. This is Hurricane Katrina approaching the coast of Louisiana. This is the storm surge from Hurricane Katrina. It was about 18 to 20 feet when it hit Louisiana, when it hit New Orleans. One of the reasons that it was so large at that point was because the coastal wetlands that had been protecting New Orleans were disappearing at a very dramatic rate over the last century. You can see that they've lost more than half of the coastal wetlands that were there originally. This is another way of looking at that. Over the last 6,000 years, the Mississippi Deltaic Plain has built up these coastal wetlands. At this point, the Corps of Engineers came in and started building levees along the side of the Mississippi River, directing all of those sediments off the edge of the continental shelf. Combined with the fact that upstream here, they were putting dams in and reducing the amount of sediments in the river overall. And the oil and gas industry was dredging canals through the coastal zone to explore for oil. So there's been a dramatic loss 65 square kilometers a year net loss in those coastal Louisiana wetlands. We also have good historical records now of where the hurricanes were, how much damages they caused, what their intensities were over a pretty long historical period. So we can build up a database that looks at the tracks of the hurricanes, how much wetlands were in the swath of the hurricane, how much infrastructure, here estimated from the nighttime satellite imagery and converted into an equivalent GNP figure, was in the swath, the maximum wind speed of the hurricane as a measure of its intensity, and how much the total damages were from each of those storms. So I know it's dangerous to put up equations in a talk like this, but here's the one equation I'll show. It's not a very complicated one, but just that we can build a little regression equation that relates the relative damages, the total damages per unit GDP, as a function of the wind speed and the wetland area. And when you fit that equation to the data, it explains about 60% of the variation in these relative damages across those different storms. There's a lot of other things going on. It's a very complicated function, but this is a significant relationship. And from that, we can derive the avoided cost. How much would the total damages be expected to go down as we increase the wetland area by 1 hectare? Or conversely, if we reduce the wetland area, how much would the damages go up? And we can then take that and create maps using also the probability of hurricane strikes along different parts of the coast historically. And we can then map out the value of these wetlands for storm protection. How much do we expect the damages to increase given the storm probabilities per year if we change the area of wetlands along the entire coast of the U.S.? You can see that the highest values occur where those 3 variables intersect, where there's a lot of infrastructure to be protected, there's a lot of wetlands there to do the protection, and there's a high storm probability to be protected from. And the bottom line here is that although there's quite a range of variation, the mean values are very high, $8,000 per hectare per year in terms of the mean value of coastal wetlands for storm protection. If you add it all up across the coast of the U.S., it's about $23.2 billion per year just for this one service of storm protection from coastal wetlands. And remember, I said there were 17 of these services that we identified for ecosystems. In this paper in 1997, we tried to synthesize all of that information and looked at all the studies we could find, like this one, that tried to estimate the value of various ecosystem services, and put that all together, came up with a value in the range of $16 to $54 trillion a year as the total value, average about $33 trillion a year for all of these ecosystem services, significantly larger than global GNP at the time. This is the way it broke down by the various ecosystems. And you can see that cropland down here had a fairly low value, not so much because it's really low, but because one of our limitations in this study were the studies that had been done. It was really a meta-analysis, and there hadn't been a lot of research done on the value of ecosystem services in cropland and other agro-ecosystems. That's since been worked on. There's more research coming out now, and one of our conclusions after this study was, even though there were quite a few limitations and caveats and problems with the paper, in fact, this was the largest section in the paper, was all the problems with it. And we listed those and identified them and went into some detail as to how they might influence the results. And our conclusions were that they would, if we solve these problems, the results would be even larger. And so it's really a very conservative estimate. And the most obvious one is that we had incomplete data. Not all of these biomes were studied well, some not really at all. And agriculture was certainly one of the ones that was understudied at the time. And new information that's come out since then, I think, verifies this basic conclusion that the values are simply getting larger. If we look at the implications of some of this for agro-ecosystems, that in fact they are producing probably larger values of ecosystem services than we had originally estimated in that paper, and that they also represent a very large percentage of the global terrestrial land surface. At the global scale, it's been estimated to be almost 14% of the surface is now in cropland or of one form or another. And in North America, it's almost right at that average figure. 13.6% of the terrestrial land surface is currently in cropland. This is just a map of the global distribution of croplands and rangelands, again from John Foley's work published in Science in 2005. You can see the natural vegetation patterns, and here's the cropland distribution
concentrated in Europe, North America, India, China, a little bit in South America, and the pastures and rangeland distribution there. This is the distribution of the value of ecosystem services based on the unit values in the Nature paper that I mentioned. So a very different distribution of wealth coming from natural ecosystems. Again, recognizing that the cropland figures are probably fairly underestimated in this distribution. I'm outlining the state of New Jersey here because recently we completed a study in more detail and with updated figures for the state of New Jersey. And I think they and several other states are beginning to recognize that this is a very important piece of information to bring into the whole decision-making process about land management and how they deal with environmental issues. And so they wanted to know what was the value of their natural capital assets in the state and the ecosystem services they're producing, and what would they be trading off and giving up if they allow various kinds of development to occur. We know also, this again is from the Millennium Ecosystem Assessment, that the degradation of ecosystem services in terms of land use changes often leads to a reduction in the total value, particularly when you're taking marginal lands for agriculture and converting them into intensive agriculture. This is a case of converting wetlands into intensive farming. You lose more than half of the total value of ecosystem services from these kinds of conversions. And likewise for several of these other conversions. We did another study a few years ago that posed the hypothesis, or posed the question in this way. It said, what is really the benefit-cost ratio of preserving our existing intact natural ecosystems and not allowing them to be converted in some of these alternative uses? And we said, well, take the scenario of expanding the global reserve network to cover 15% of the terrestrial biosphere, 30% of the marine biosphere. That would cost us about $45 billion a year to implement, to buy the land and the rights and et cetera, and to manage the system. The benefits would be the net value of the ecosystem services from this global reserve network minus the alternative uses of those lands if they were converted into the next likely alternative. Those net benefits were $4 to $5 trillion, 4,000 to 5,000 billion per year. So the benefit cost ratio was 100 to 1, a very good investment from society's point of view. And the only better benefit cost ratio I've seen is for oil companies investing in political campaigns in the U.S., which has been estimated to be about 400 to 1. So there are also good economic reasons for restoring and improving the ecosystem services in agroecosystems. So as I pointed out, because of the large area of croplands that we have now, if we can make improvements in the ecosystem services coming from them without significantly reducing crop production, then we can make a huge improvement in the value of these ecosystem services globally. If you think of total global cropland of about $1.8 billion per hectare, the latest figures I've seen for the value of cropland ecosystem services more recently is about $1,000 per hectare per year. So we can double that without too much effect
on crop production, and we could increase the value of these services by close to $2 trillion a year. And of course, we know the cost of the war in Iraq has been about $3 trillion a year, so we could recover a big chunk of that. Let me get a drink of water here. So that's the, the natural capital story. Social capital is also extremely important. I don't have time to really go into too much detail on this, but just to point out the importance of social capital. This is from some work by Robert Putnam in his book Bowling Alone, where he created an index of social capital by state for the U.S. based on participation in bowling leagues and religious organizations and voting participation rates and et cetera. And he got this distribution across the different states. And he also pointed out that this social capital index was highly correlated with very good things and negatively correlated with bad things, that violent crime is rarer in high social capital states, kids watch less TV in high social capital states, schools work better in high social capital states, health is better in high social capital states. So it has a real influence on a lot of other indicators that, that are important to us. I think we need to go further in these sorts of analyses. Most of what I've talked about has been very static in its analysis. And we need to build more integrated, more sophisticated modeling tools for looking at how humans embedded in ecological systems behave. And I think to do that, we need to take a more pluralistic approach to modeling. There's not one right way to do this. But as several people have pointed out, all models are wrong, but some models are useful. So we need to be able to distinguish the relative usefulness of different models and not pretend that any of them are going to give us the answer. Recognize that there's always going to be uncertainty and limited predictability associated with any of these models. And take a more pluralistic approach and use cross-calibration and comparison of different modeling approaches and better approaches to testing and integration. Recognizing that we have to do these things in multiple scales, in time, in space, in complexity. We can't look at the systems at just one scale. We have to look at the local, the regional, the global scale. We have to look across many time scales as well. We can also use this process of building models as a way to build consensus in a more open 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 consensus and participatory process. So we've done this quite a lot. It's called mediated modeling. You can or contribute participatory modeling. So you can get a group together around a table and say, let's focus on building a computer model of our system, and get people to work together on that problem. And that tends to overcome many of the long-term conflicts that might have built up. And it allows people to then understand and think of the model more as a community product that they will then be able to use the results of more effectively. It also recognizes that we're talking about historical contingencies, an evolutionary approach. There's limited optimization that can go on, and that human cultures evolve and change in the same way that biological systems do, and we have to recognize that evolutionary process. This is just an example of a recent book that includes several case studies of applying this sort of approach of integrated modeling at the landscape scale, largely, that allows us to look at the complex interactions over time and space of both the ecological components of the system and the economic components of the system. More recently, we're working on a series of models called MIMES, the multi-scale integrated models of ecosystem services, that basically allow us to do at a range of different spatial and temporal scales to look at the entire system here, including the biosphere, hydrosphere, lithosphere, atmosphere, and troposphere, the human part of the system, the built human and social capital components, including human well-being as an explicit component, and how ecosystem services affect that human well-being, both through the production of conventional goods and services, but also in the more direct way. And this modeling framework allows us to apply it at many spatial scales. The idea ultimately is that one could take a Google Earth type of interface, identify a particular part of the planet or the entire planet, and then be able to download a running simulation model that would give you the temporal and spatial dynamics of ecosystem services in that particular region. We're doing a bunch of testing and application at some calibration sites of this process now, and we're intending to get results that look something like this. So we could apply it at the global scale. This would be a couple of the input variables out of hundreds of variables in this model, but for example, the influence of land use and soil drainage type on the water regulation service at the global scale, and then applying the same model at smaller watershed scales. So the idea is that the model framework, the basic model structure would be the same. The parameters would be recalibrated at this smaller scale. Let's see. And getting more into the policy component. So what do we do with all of this kind of information? Well, I think one of the things we need to do is to use it to make the market tell the truth. The market's really not telling us the truth about the costs and benefits of our activities because it's leaving out all of these non-market goods and services, ecosystem services, natural capital, social capital. The answer is not privatization in general, because most of these services are not private goods, they're public goods. But we can adjust the market signals and incentives to take the value of these non-market goods and services into account. You can do full cost accounting. I don't know why you can't see this one, but there's a company I'm involved with called True Cost that tries to estimate the external environmental cost by company. Did I put that in here? Yeah, so here's the website. And then make that information available to investors and fund managers and the companies themselves so they can rank the companies based on the quantitative amount of external costs that they're incurring, and not the more subjective kinds of indices that have been used. On the negative side, we could say let's reform the tax system to tax bads like the depletion of natural and social capital, and not goods like labor and income, and remove perverse subsidies. So let's use the tax incentives in a positive way to send the right kinds of signals. And on the plus side, we could take some of those tax revenues and pay people for providing ecosystem services. In Costa Rica, they have a fairly elaborate system of payment for ecosystem services. And one could think about revising the agricultural subsidy system to pay for social benefits like ecosystem services from agricultural systems rather than what we're subsidizing now. We could think about charging impact fees for new development that's actually tied to the real impacts. So how can we send the right signals to developers if they really had to pay for the impacts on both the built infrastructure but also the natural capital and social capital? And with the kinds of modeling and other techniques that I'm talking about, we could develop estimates of what those impacts are, and then allow those impacts to vary depending on what their plans are. We could direct development into much more productive and benign types. There's always going to be uncertainty in all of this, and I think the real key here is to change the burden of proof towards the parties that stand to gain from the activities and away from the general public. So one idea here is to charge environmental assurance bonds to incorporate this uncertainty, to charge potential polluters for the potential damages and allow those bonds to be refunded if and when those damages are shown to be less than what they might have been. So this is a way of applying the precautionary principle and combining it with the polluter pays principle and shifting the burden of that uncertainty onto the appropriate parties. and we can expand the common sector in general, as we were talking about. One way of thinking about a general set of principles that we would need to build more adaptive institutions that are consistent with this full world vision of the economy is this list that we came up with in this paper, and it's also in the handout that you can download from the website. But just to quickly go over them, the responsibility principle says that the rights to use resources carry attendant responsibilities to use them sustainably, that we have to match the scale of the institutions that we're using to control problems with the scale of the problem. Global scale problems require global scale institutions, and likewise for other scales. The precautionary principle really implies changing the burden of proof to away from the public to the parties that stand to gain from the activity. Adaptive management implies that we learn from our policies and not consider our policies to be the solutions to these problems, but consider them to be experiments that we're running on the system that we need to learn from. Allocate the costs so that we can actually have real economic efficiency. And lastly, to encourage participation in the process as early in the process as possible, from hopefully from the development stage all the way through. This common sector of the economy, I think, already is beginning to expand. We need to increase the rate of expansion and to think about new ways to involve and create the common sector. So things like land trusts at the local and regional scale, and farmers markets and time banks and other things are examples of commons. At the regional scale, we can think about regional watershed trusts. And all the way up at the global scale, we can think about an atmospheric trust or an oceanic trust. And I'll talk a little bit more about this in a second. We also need to rethink what the corporation means and how we define the goals of corporations. We as part of a course, we developed and incorporated this NGO called Earth Inc. If the Earth were a corporation, what would the shareholders report look like? What would our assets, how would we describe our assets and our share value per shareholder, which is everyone on Earth? So we'd have to redefine what profit meant in terms of the natural, social, human, and built capital components. And one idea for implementing this was this Earth Atmospheric Trust. Getting back to the issues of climate change, we know that if we continue business as usual, the concentration of CO2 in the atmosphere is going to increase dramatically. If we want to maintain a concentration of 450 parts per million, we not only have to level off production of CO2s, we have to dramatically reduce it over the coming time period. And some are arguing, like Jim Hansen, that we really need to get down to 350 parts per million, which would require even faster reductions in CO2. How are we going to do that? Well, one idea is to create this atmospheric trust, which would not only stop the emissions and reduce global warming gas emissions, but also reduce and address the poverty issues at the same time. We would create this trust, set up a global cap and trade system, but then auction off all of the permits for emissions into the atmosphere. And then we take the revenues and then gradually reduce the cap to follow this 450 or 350 part per million target. As we did that, the price of those permits would probably increase. We take the revenues from those auctions, put them into this trust fund, and then return a fraction to everyone on Earth on a per capita basis as a dividend from their asset, from their common asset of the atmosphere. This would both address the global poverty issue, and it also function to allow countries like India and China to sign on to this kind of system because they would be net beneficiaries. And then use the remainder of those revenues to enhance and restore the asset directly, investing in renewable energy and payments for ecosystem services such as carbon sequestration, et cetera. I don't know if you can see this very well, but this is in the paper as well. I won't spend too much time on it, but this is kind of a summary of some of the things I've talked about. Our current development model is very much based on the empty world vision of the world. The primary goals are more, We measure it as GDP. We don't really worry about distribution or scale, and that property rights are fairly simple. The role of government's to be minimized, and the laissez-faire market capitalism is the primary principle of governance. What we need to move more towards in this full world context is primary goals that focus on better rather than more, shift away from growth to real development as measured by GPI or something similar to that, that we have to worry about scale, we have to worry about distribution, and we have to worry about efficiency in a more balanced way. We have to develop more nuanced and new approaches to property rights and property rights regimes that are more complex and more adapted to the nature of the system. We have to have a revitalized role for government, but maybe a different role, that it acts more as a facilitator and broker rather than as a direct regulator. And we need a set of principles for governance like the Lisbon principles that I mentioned. As far as agroecosystems are concerned, they represent this unique mix of natural and human-made capital. This modern industrial agriculture has tended to ignore ecosystem services, but we could bring those back into the picture and create a more diverse kind of agriculture that produce not only crops, but also this whole range of ecosystem services. If we did that, we can increase the value of those croplands to society by I think, significant amounts, as much as $2 trillion per year globally. And that new institutions might be necessary to help us achieve that sort of transition. And finally, I think we need to start concentrating more on the solutions to some of these complex problems and not focus so much, as we have in the past, on elaborating the problems in more and more detail. We're starting a new journal, sort of web presence, devoted to just that discussion. How can we have a discussion of integrated solutions across a whole range of disciplines and inputs? And so I encourage you to look out for this, and if you have some good ideas, to send them into us as possible contributions to this new journal on solutions. And thank you very much. And if you want copies of any of the papers that I mentioned in this talk, in addition to the one that is on the website, you can go to our website here. Sure.
So we have time for questions. At the end of that, we'll have a small reception, food and drink in the back. And right now, I think we can use this mic here if we can get it live. You can step up, and pose a question directly to Dr. Costanzo.
Thank you, Dr. Costanzo. That was an excellent presentation. I appreciate you coming. I noticed there was a lack of information about the bioeconomy per se, and just wanted to get your group's viewpoint on it. I can see people would look at it from two different aspects of providing ecosystem services because it's increasing crop production. Farmers are planting fence row to fence row and using a lot of fertilizer to produce a lot more biomass, ergo getting more ecosystem services according to your definition. But somehow I feel you might have a little alternative view, but I didn't hear it in the presentation. I was wondering if you can comment on it.
Well, I think it's a much more complicated and nuanced picture than that. And I think maybe this graph presents it a bit more, that there's a whole range of ecosystem services that we can think about producing from cropland, in addition to crops or energy crops or food crops, either of the two. And so I think what we need to do is to take all of these other things also into consideration. The air and water quality, carbon sequestration, habitat and biodiversity, et cetera. So I think there's a lot of new ideas out there, and probably coming from many of you guys on how we might create forms of permaculture and alternative approaches to agriculture that are a better balance, that are more like the right-hand picture here and less like the middle picture. And that sort of approach will give us a larger social value for cropland, while at the same time not necessarily diminishing our crop production. Yeah.
Hello, thank you for your talk. I am a student in construction engineering, and I think my industry is going to have significant impacts by sustainability. And I don't know, I'm not sure if you've realized or have heard about the recent floods and tornadoes in Iowa this past summer, but I've started up a student organization to help with the volunteer effort there.
Mm-hmm.
But part of me is troubled because we're just simply rebuilding houses the same way they were to get
Right.
people back in their houses as quickly as possible.
Right.
And I see the stories and I hear about the people, and it brings tears to your eyes, the stuff these people have gone through, and you just want to do anything you can to get them back in their house. How do we deal with that apparent dynamic there?
Well, I think that's a challenge for the design professions. Actually, my master's degree was in architecture, and so I'm very sensitive to that sort of issue. And I think we need to redesign our built infrastructure, as well as our natural and our social infrastructure, to be more cognizant of some of these issues. We did some work in New Orleans, or some thinking anyway, about how would one rebuild New Orleans. You certainly don't want to just replace the infrastructure that was there, because that's just setting the pins up to be knocked down again. You want to rethink how that infrastructure actually is built, building houses up above the flood zone, which some people are doing, building houses that can float if there is a flood. So recognizing that these are things that are going to happen, and not denying the possibility, but working with the natural forces and not against them. But I think it's a real challenge, and I think we need to think about rebuilding a lot of our built infrastructure in ways that are less energy intensive, less more green, as it's called. But I think there's a lot of room for new thinking and new research there, and I think that's one of the things we'll try to present in this new journal called Solutions. How do we integrate the built infrastructure with a more desirable and sustainable overall system? Yeah.
Yes. Well, I really agree with your thoughts about moving away from talking about problems and talking about solutions. But it seems like to me that the vast majority of the population of the world does not recognize the problems. And so you must have given a lot of thought about how to accomplish that. How would we do that? How would we move from talking about problems to solutions?
Well, I think one of the reasons that people don't want to recognize the problems is because there aren't solutions that follow. That if we had some solutions to put on the table, that they would be willing to recognize that, in fact, they are solutions to problems that do exist. So we're in a state of denial, I think, in a lot of cases, and it's easier for people to simply not want to acknowledge the problems if they don't see a real solution. And I think one of the limiting factors, too, is that we haven't painted the picture of a sustainable and desirable society where people would actually be better off than they are now, would be happier than they are now, rather than it be a sacrifice. I think a lot of the environmental movement and a lot of the what comes out that people perceive is that making these changes is going to be a big sacrifice. We have to give up a lot of things that we now have. And I think it's just the opposite. I think it's a sacrifice to keep doing what we're doing. It's a sacrifice not to make the appropriate changes. We could be significantly better off. But we have to elaborate that and paint that picture and get that message out to the general public. And we were talking about this earlier in some of the courses. I think we really need to enlist the services of Hollywood, of the media that can reach these larger audiences. Why don't we start producing some movies that are set in a positive vision of the future, rather than the dystopias that we normally see as visions of the future in the movies. Could we produce some soap operas that embody these kinds of ideas? I think that's what you need to reach these broader audiences that you're talking about. At least that's one thing that might work that we haven't really tried yet. Yeah.
Thanks. Thank you very much for your talk. This might be a little bit far afield, but as you were talking, I was thinking about, all right, well, when in history have societies tweaked their own economic systems because it made sense? Because it seems to me like what you're suggesting. And it seemed that it happened in the 80s. I mean, it seemed that that's what the privatization under Reagan and Thatcher were really designed to do. And it seemed that that occurred in this geopolitical context of a Cold War or a post-Cold War world. And so I was trying to think, do today's geopolitics inform this? Do they support this? Do they work against it? Do globalized markets challenge this? Or are there currents? Dr. Liebman mentioned September 11th. Is the local geopolitical or the current geopolitical situation working with this idea or against it?
The current geopolitical situation in the U.S. or in other countries, I think there's quite a variation around the world, but certainly in the U.S. it's not working with us or with this, at least not yet. But I think it's interesting, and Peter Barnes in his book about Capitalism 3.0 points out that these things go in cycles, and there are periods when an opportunity presents itself and when a window opens for new ideas to occur. And sometimes it takes a major crisis for that to happen, like the Great Depression or other things. And I think our challenge is to be ready when that window opens to have the alternative and say, here's a better way. I'm not sure that it's fruitful to push the agenda much harder than that. You just have to wait for the right time for it to happen. Yeah, and I think that the political climate is changing and is always changing, and it changes, in unexpected ways. So it's hard to know exactly when that window's going to present itself.
I had another one if no one else does.
Pardon?
I had another one if no one else does.
Okay, go ahead.
Just the idea, it seemed like a lot of this was macroeconomics. Do you envision a microecological economics, and is that something that would come later, or is it a concurrent development?
Well, I think it's really intended to be at multiple scales, from micro to meso to macro, and I think that's one of the key ideas there is you have to integrate across all of those different scales. I can only say so much in 1 hour, but there's a lot of activity also at the micro scale, and how you design smaller scale sustainable communities, co-housing and eco-villages and things like that. How do we enhance quality of life at those scales, and then all the way up through the global scale? Others? Oh. That's an easy question.
Dr. Costanza, did I understand that you introduced the concept of a watershed trust? If you did, yes. Could you elaborate on what that might look like?
Well, let's see. I think that would be, an NGO type of or quasi-government organization that had the watershed as its asset that it was trying to protect and maintain. So it would be, propertizing the watershed, giving property rights to the entire watershed on behalf of the community that lived in the watershed, and then damages to that watershed that are external to the market would be something that you could charge for, and you could use the revenues to pay for positive things going on in the watershed, like riparian vegetation, replantings. You could pay private owners to do that, and pollution of water in the watershed is something you could charge fees for. So in a sense, it's not taxing those activities. It's just recognizing that those are damages to an asset. And in a market economy, you don't get away with damaging other people's assets without paying for them. So that's the basic idea.
Do you see that as possible on a voluntary basis, or would that take a state or federal authorization?
I think it would take some government, to set up the system. And we certainly have things that are not far away from that in existence already. We have private land trusts. So if you buy the property or buy the easements on the property, from the landowners, you can certainly create that sort of system. That exists. In Florida, they have water management districts that basically are on watershed boundaries, and they have taxing authority and they have regulatory authority over what goes on in those watersheds. So there are precedents in various parts of the country for some aspects of this sort of system, and this would just be a way of putting a lot of those things together, maybe under one umbrella.
Thank you very much.
I especially appreciate your effort to be optimistic in this context, and I appreciate it because I find it very difficult myself. But so I'm going to put a ground for pessimism on the table, and I want you to make me optimistic about it.
Okay.
When you point out that paying appropriate costs for ecosystem services really is a cost-effective solution, I think you're right. But I worry that it's a cost-effective solution for society, and that there are a lot of individuals within society whose interests diverge very significantly from the long-term interests of society. So like the oil companies that get these enormous returns on investment in political lobbying, I think there are people who can get enormous returns, immediate returns, on present inappropriate environmental activities. And the people who pay the cost are people who aren't here yet. They're people who will be our children and our great-grandchildren. And I think we need to focus on the development as well, on the development of institutions that turn those incentives around. I hope that's a question.
It didn't sound so pessimistic to me, actually. That's in fact what governments are for, is to protect the social interests from private interests when those are not consistent. I mean, the dominant paradigm, the free market paradigm is those are always consistent. If everybody just pursues their own private interests, that will lead to the social good. But in fact, we know that it doesn't always. And the reason it doesn't is because not everything is a private good. If everything in the world, were private goods and we had property rights over all of those things, and there's this whole long list of assumptions that are required for that conclusion to hold, and those assumptions are very far from holding in reality. I mean, the problem with, I think, many economists is that they confuse the model with reality. It's called the fallacy of misplaced concreteness. They confuse the map with the territory, and when reality doesn't conform to the model, they say, well, let's change reality. So I don't think we necessarily want to go that way. We want to better distinguish between those things that the market can handle and those things that it can't, and where we actually need other institutions. And certainly, it's not impossible. Other countries do a much better job of this than we do. So in Scandinavia, I think, for example, they do a much better job of recognizing that distinction and dealing with it. And I think we have that as an existence proof. It's certainly possible to do, and we could move more in that direction, and we should.
Thanks for coming to Ames. As I listen, I have visions of lab animals that reproduce themselves into oblivion with the limited resources, and we certainly have limited resources on the planet. I see part of the solution as educating and bringing people along to see what's inevitable if we don't make some changes. Do you think the human race is capable of learning fast enough to avoid calamity?
I think it is capable, yes. I think that's the reason that we've become the dominant species on the planet, is the fact that our cultures, our behavior can be passed on, through learning and not just through genetic inheritance, and that cultural evolution can happen very quickly relative to biological evolution. And I think our challenge is to sort of understand that process better and get ahead of it and create alternatives that are going to be selected, that are better alternatives than the ones that we have now. Evolution also doesn't necessarily lead to the best solution in all cases. We can get locked into certain behaviors that are not necessarily the most adaptive, and I think that's part of the problem, is that we end up in what I call investment traps. We have a lot of investment in the existing infrastructure and ways of doing things and ways of thinking about the world, and our whole system is really a huge investment that, in conventional economic thinking, that's a sunk cost. We shouldn't really think about that. But in fact, we tend to think about it quite a lot, and we want to justify those investments rather than writing them off and saying that's the past. So it's not an addiction is a similar kind of investment trap or trap that we keep doing things because they keep reinforcing themselves. So getting out of those kinds of traps, I think, is not easy, and it's not simply a matter of you can't tell a drug addict that you should just stop. Well, they may know that, and they may know that there's a better way, but actually breaking the addiction takes some other kinds of activity. But that doesn't mean that it can't happen. It just means that we have to recognize some of those difficulties and don't expect it to happen just immediately as soon as we point out the fact that it's not the right way to go. So there is a certain amount of patience required, and we also probably need a 12-step program or something to help us get out of these consumption addictions. Yes.
Again, thanks for the talk. And a couple times you've mentioned the issue of scale. And I'm wondering if you might talk about what economic activities you think are appropriate at what scale. For example, what economic activities are appropriate at a local, regional, national, global scale in the green desirable future?
What economic activities? I don't know. I can see any.
I guess a related question would be, what's the progressive role for globalism in this future?
Okay. Well, I don't think that sustainability requires self-sufficiency at the very small scales. I think there's always going to be a role for trade of some kind. And we've had, global trade for hundreds of years now. So it's really just the magnitude of that trade that's expanded, and it's really expanded largely because of the apparent cheapness of fossil fuel and transportation. And I think that will change, and it will become more expensive to ship things around over long distances, and so that will mean moving back to only trading small volume commodities that are relatively easy, high value, small volume commodities that are easy to ship over long distances. And that will require more reliance on the more local economies for a larger percentage, particularly of our bulk commodities like food. So I don't think we're going to ship food quite as far as we have in the past, and we'll be forced to move to a more local kind of food production systems, at least for some things. I mean, there will still be some things that'll be worthwhile shipping for long distances. If that's what is that what you're getting at? Yeah. But again, I think the key thing is to refocus not so much on let's just make and ship as much as we can, but recognize that we're really our goal really should be creating a higher quality of life for a larger fraction of the planet for a longer period into the future, and whatever that takes. So it may mean producing less in some places. It may mean producing more in some places and shipping it to the places that really need it more than we do. So it's hard to predict what that complex pattern is going to look like. But I think if we change our fundamental goals and have a clear vision of what the kind of society we want to create is, that those other details will work themselves out.
Do we get two questions? Do you think that we have a sustainable population in the world today?
And the second question?
Well, I asked one earlier.
Or you want to wait for the answer to that one
No,
first?
I asked one earlier.
Oh, okay. Well, I think this gets back to the quality of life issue fundamentally. I mean, we probably could sustain the number of people that we have on the planet today, but that means, you know, as resources become depleted, at a lower quality of life. So is that what we want, or do we want to have a fewer number of people at a higher quality of life? So there's that trade-off, you know, the sort of famous IPAT equation. You know, you can't have both. I think it's certainly possible to stabilize global population and even reduce global population, you know, with the appropriate policies and education of women and et cetera. So I don't think that's sort of in any way impossible. And I think that's a social decision that we have to make. Do we want more people at a lower level or less people at a higher level? And I would argue that you know, we should take the steps necessary to try to stabilize population as soon as possible, because we are outstripping our resources, and I would prefer to have, you know, at least the current population at as high a level of well-being as we can. But it also implies, I think, more of a focus on the distribution of wealth or redistribution of wealth, and less of a focus on just producing more and more and assuming that that's going to be, you know, distributed well. History has shown that it doesn't really work that way. I mean, the conventional approach is a rising tide lifts all boats. Let's just, you know, increase GNP and everyone will be better off. But the reality is that rising tide only lifted all yachts, and everyone else was left, you know, at the bottom of the sea. So if we were better at addressing those distribution issues, I think that would also have more of an impact on the policies that we create about population. Did that help? All right.
Okay, seeing no more questions, let's eat, let's drink, and let's thank Dr. Costanzo.